They say a mature bald cypress in the Louisiana bayou could stand 130 feet tall, with a trunk 12 feet across at the waterline, its roots spreading through black mud that swallowed a man to his chest. But in the 1880s, those trees didn't float themselves out of the swamp by asking nicely. They came out screaming, dragged by machines that ran on steam, chain, and the kind of desperate ingenuity that only exists when an entire industry is drowning in its own success. We're talking about operations that could pull a 50-ton log through a half-mile of standing water and sucking mud, using nothing but a boiler, a drum, and physics that would make a modern engineer file for a restraining order. No solid ground, no roads, no way to get heavy equipment in or timber out, except by sheer mechanical violence and the labor of men who understood that every shift was a negotiation with quicksand and steam pressure that could turn a boiler into a bomb. Today, we live in a world of all-terrain vehicles and GPS navigation, of wetland protection regulations and OSHA swamp safety protocols. But there was a time, not so long ago, when America's appetite for cypress, tupelo, and southern pine demanded that men go into places where the ground wasn't ground at all, just a thin skin of roots and rotting vegetation over water that never saw sunlight. This is the story of how timber came out of the swamps, the iron contraptions that made it possible, the men who operated them standing waist-deep in water while managing equipment that could crush them or scald them without warning, and the economic forces so powerful that drowning an entire forest in order to harvest it seemed like a reasonable business plan. Let's set the stage. The year is 1885. America is building. Cities are rising along the coasts and spreading inland. New Orleans needs timber for docks and warehouses. The railroads are pushing south and west, demanding ties that won't rot in humidity. Every new town, from Texas to the Carolinas, wants boards that can withstand moisture, insects, and time. And the best wood for all of that, the wood that could last a century in wet conditions, was standing in swamps where no horse team, no ox cart, no standard logging operation could reach it. Bald cypress, Taxodium distichum. The wood is so resistant to decay that samples pulled from swamps have been dated to over 1,000 years old and still show no significant rot. The heartwood contains cypressine, a natural preservative that makes it nearly immune to termites and fungus. When you cut into a mature cypress, the smell is sharp, almost medicinal, a chemical signature of its own immortality. These trees grew in standing water, sometimes 3 or 4 feet deep year-round, their trunks swelling at the base into buttresses that could measure 20 feet in circumference. The roots didn't just anchor the tree, they created knees, woody projections that jutted up out of the water like snorkels, allowing the root system to breathe even when submerged. A single tree could yield 10,000 board feet of lumber. In 1880, that was worth $500 delivered, roughly $15,000 in today's currency. But delivered was the problem. The trees stood in places that had no roads, no solid ground, often no dry land for miles. The water was stained black with tannins from decaying vegetation, deep enough to drown a man, thick with submerged roots and hidden logs from previous storms. The bottom wasn't mud in the normal sense. It was a organic soup, part silt, part decayed plant matter, with the consistency of wet concrete. A man walking through it would sink to his thighs. A horse would sink to its belly and thrash itself to death trying to get free. Standard logging techniques, the kind that worked in the forests of Maine or the Sierra Nevada, failed completely. You couldn't build a skid road because there was nothing to build on. You couldn't use horse teams because the animals couldn't stand. You couldn't float the logs out easily because cypress, for all its virtues, is denser than most pines and doesn't float high. A green cypress log in the water rides low, and if it tips, it sinks. For decades, swamp timber was considered unreachable, a known resource that economics couldn't touch. Then the demand got so intense and the price got so high that economics found a way. The solution required rethinking everything. If the ground won't support equipment, don't use the ground. If horses can't work, don't use horses. If you can't build a road, build a railroad. But not a normal railroad, a railroad that floats. The ingenuity came from men whose names are mostly forgotten now, camp bosses and engineers working for timber syndicates with names like the Lutcher Moore Lumber Company and the Louisiana Cypress Company. They started with the simplest possible premise. Cypress grows in water. Water connects to rivers. Rivers connect to mills. If we can get the logs into a controlled waterway, we can float them out. The problem was getting them from where they stood, deep in trackless swamp, to a river or canal. The tool they developed was called a pole boat, though the term doesn't do it justice. Imagine a flat-bottomed barge, 60 feet long and 20 feet wide, built of heavy cypress planks and reinforced with iron straps. Mounted in the center is a vertical steam boiler, 6 feet tall, riveted steel, fired by wood scraps, and capable of generating 150 pounds of pressure. Next to the boiler sits a massive drum, a cylinder of iron 4 feet in diameter, wrapped with thousands of feet of steel cable. The whole assembly weighs 15 tons. It floats. Barely. The pole boat was positioned in a channel, sometimes a natural waterway, sometimes a ditch dug by hand crews over weeks of labor. The channel had to be deep enough to float the barge and wide enough to maneuver. From the drum, a cable ran out into the swamp, sometimes a quarter mile or more, threading through the trees and over the submerged roots. At the end of that cable was a choker, a loop of smaller cable or heavy chain that wrapped around a felled log. When the steam engine turned the drum, the cable wound in, and the log, all 50 tons of it, was dragged through the water and mud toward the barge. This wasn't gentle. The log plowed through everything in its path, snapping saplings, tearing up root mats, churning the water into a black froth. The noise was a constant grinding roar, the hiss of steam, the clank of chain, the groan of wood under impossible strain. If the log hit a stump or a submerged obstacle, the cable would go taut and the entire barge would lurch forward in the water. If the obstruction didn't give, something else had to. Either the choker slipped, or the cable snapped, or the log itself split apart. Operating a pole boat required a crew of 4. The engineer managed the steam engine, throttling pressure, engaging and disengaging the drum clutch, watching the cable for signs of overload. The fireman fed the boiler, shoveling wood into the firebox in a rhythm dictated by the pressure gauge. If the pressure dropped, the pull stopped. If the pressure spiked too high, the boiler could rupture, releasing superheated steam in an explosion that would kill everyone on the barge and likely sink it. The hook tender worked out in the swamp, waist deep in water, setting the chokers around logs that had already been felled by separate crews. This was skilled and dangerous labor. The choker had to be positioned correctly or it would slip when tension was applied. The hook tender had to clear debris, sometimes using an axe while standing in unstable mud, then signal the barge to start the pull. He worked alone, out of sight of the barge crew, communicating by whistle signals or, in later operations, by a lighter pull line that ran parallel to the main cable. The deckhand managed the cable on the barge, guiding it onto the drum, watching for kinks or frays, and clearing jams. A kinked cable under load could snap without warning. A frayed cable was a time bomb. The deckhand's job was to catch problems before they became fatal. Let's talk about the cable itself, because this is where the physics gets brutal. Steel cable for a pole boat operation was typically 3/4 of an inch to 1 inch in diameter. It was made of multiple strands of high-carbon steel wire twisted together for flexibility and strength. A 3/4 inch cable could handle a working load of around 20,000 pounds. But working load is a fraction of braking strength, and braking strength assumes the cable is new, undamaged, and not subjected to shock loads. In the swamp, none of those conditions held. The cable ran through water filled with acid from decaying vegetation. It scraped over submerged logs and roots. It kinked when a pull went wrong and had to be straightened by hand. Every shift introduced new weak points, invisible fractures in the wire strands that propagated under load. When a cable snapped, it didn't just fall. The stored energy in a tensioned cable releases instantaneously. The cable whips, moving faster than the eye can follow. Men were cut in half, limbs severed, skulls caved in. The old-timers would tell you that if you heard the cable start to sing, a high-pitched vibration under extreme tension, you hit the deck immediately because it was about to let go. The logs themselves were felled by separate crews, working ahead of the pull boat. These men were fallers, the same breed that worked the Pacific forests, but their environment was entirely different. They worked standing on platforms built over the water or balanced on floating logs. The undercut and backcut had to be made while standing in a space that shifted and swayed. The misery whip, the long two-man crosscut saw, was used, but the rhythm was harder to maintain when both men were struggling for footing. When a swamp cypress fell, it didn't fall onto solid ground. It fell into water and mud, sometimes disappearing entirely beneath the surface. The fallers had to mark the location, and later crews would have to probe the murk with long poles to find the submerged log and get a choker around it. The root ball, that massive tangle of wood and mud at the base, had to be cut away. This was done with axes and saws, often underwater, the men working by feel as much as sight. A faller in the swamp could expect to be wet all day, every day. There was no dry place to rest. Lunches were eaten standing in water. Infections from cuts and scrapes were common because the swamp water was a bacterial soup. Malaria and yellow fever were occupational hazards. Entire crews would be laid low by fever, and the company would just bring in new men. The economics of the operation were staggering. A good pull boat could move 20 to 30 logs per day. Each log, if it averaged 8,000 board feet, represented $400 in raw timber value. A single barge operation could generate $12,000 in timber per day, roughly $360,000 in modern terms. The operating costs were significant but manageable. Coal or wood for the boiler, wages for the crew, maintenance on the equipment, and the constant replacement of cable. The profit margin was fat enough that companies could afford to lose equipment and men and still come out ahead. That calculus, profit versus human cost, defined the industry. Men were expendable. Equipment could be replaced. But the timber, that irreplaceable resource, had to come out. The environmental impact was total. Swamp logging didn't harvest a forest. It destroyed an ecosystem. The pull boats and the logging operations that supported them required access channels, ditches cut through the swamp to float the barges and move the logs. These channels drained the standing water, altering the hydrology permanently. Once the water level dropped, the remaining trees died. The root systems, adapted to standing water, couldn't survive in drier conditions. What had been a living swamp became a desiccated wasteland within a few years. The timber companies didn't care. Their model was extraction, not sustainability. Cut everything of value, move to the next swamp, repeat. By the time a logged-out swamp had turned into a mudflat, the company was 100 miles away, cutting a new tract. The scale of destruction is hard to grasp. Louisiana alone lost over 90% of its original cypress swamps. Florida's cypress strands were stripped. The Atchafalaya Basin, once a nearly impenetrable wilderness of old-growth cypress and tupelo, was reduced to second-growth scrub within a generation. Millions of acres, ecosystems that had existed since the last ice age, were converted to board feet and shipped north. But let's return to the machinery, because the pull boat was only the beginning. As operations scaled up, Companies needed to move more logs faster. The pull boat could drag logs to a channel, but then what? The logs had to be assembled into rafts, massive floating structures that could be towed down rivers to the mills. Building a raft was an art. The logs were corralled in a holding area, a widened section of the channel, and then bound together with chains and cables. A raft could be 200 feet long and 50 feet wide, containing hundreds of logs, thousands of tons of timber. These rafts were towed by steam-powered tugs, shallow draft vessels with rear-mounted paddle wheels. The tugs were purpose-built for swamp work. They drew only 3 or 4 feet of water and could navigate channels that would ground a conventional riverboat. Towing a raft through a narrow, winding bayou was a feat of seamanship. The raft had no steering. It went where the current and the tug pushed it. If the tug lost power or the tow cable snapped, the raft would drift into the banks, jamming the channel and requiring days of work to free. Tug crews worked around the clock during the towing season, which was dictated by water levels. Too low and the raft would ground. Too high and the current was unmanageable. The window was narrow and the pressure was immense. Then there were the steam skidders, a different approach to the same problem. Where the pull boat worked in open water, the steam skidder was designed to operate on marginally solid ground, the edges of the swamp where the mud was thick but not quite liquid. A steam skidder was essentially a portable steam donkey, similar to the ones used in the Pacific Northwest, but mounted on a sled instead of wheels. The sled distributed the weight, allowing the machine to sit on soft ground without sinking completely. The skidder had a drum and cable system, but instead of pulling logs through water, it dragged them across mud. The operation was similar. Fell the tree, set the choker, signal the skidder, and drag the log to a collection point. The difference was the terrain. Mud has different properties than water. It's denser, more resistant, but also more unpredictable. A log being dragged through mud could suddenly hit a solid layer and stop dead. Or it could break through into softer mud and sink. The skidder operator had to feel the load through the tension in the cable, adjusting power constantly. Too much power, and the cable snapped, or the log rolled. Too little, and forward progress stopped. It was a constant, tactile negotiation with the earth. The men who worked as choker setters for the skidders had arguably the worst job in the entire operation. They worked in the mud zone, the transitional area between solid ground and open water. The surface looked solid, but it wasn't. A man could take a step and sink to his waist, the mud clamping around his legs with a suction that made it almost impossible to pull free without help. Choker setters worked in pairs for safety. If one man went down, the other could throw him a rope or a pole, but sometimes both men went down. The company ledger for the Caddo Lake Cypress Company, operating in the Texas-Louisiana border region in 1900, lists 6 choker setters lost to drowning in mud in a single year. Drowning in mud is a specific horror. It's slow. The mud fills your boots, pulls at your legs, and as you struggle, you sink deeper. Panic makes it worse. The more you fight, the faster you go down. The men who survived these situations described a cold clarity that set in, the realization that thrashing meant death, and that the only chance was to spread your weight, move slowly, and hope your partner could reach you in time. Let's talk about the steam technology itself, because understanding the machinery means understanding the risk. A steam boiler is a pressure vessel. Water is heated until it turns to steam. Steam occupies more volume than liquid water, creating pressure. That pressure is harnessed to do work, driving pistons or turbines. But pressure is also potential energy. If the vessel fails, that energy is released explosively. Boiler explosions were not uncommon. A poorly maintained boiler, a stuck pressure relief valve, a fireman who let the water level drop too low, any of these could lead to catastrophic failure. When a boiler exploded, the results were devastating. The boiler itself could be propelled hundreds of feet, a multi-ton projectile. The steam release was a cloud of superheated vapor at 300 degrees or more. Men caught in the blast were scalded to death. Shrapnel from the bursting vessel cut through flesh and bone. The barge or skidder that housed the boiler was destroyed. In 1903, a pull boat operating in the Pearl River Basin in Mississippi suffered a boiler explosion. The engineer and firemen were killed instantly. The barge sank. The deckhand, who had been forward when the explosion occurred, survived but was permanently blinded by the steam. The hook tender, working a quarter-mile away in the swamp, heard the blast and found the wreckage an hour later. There was no rescue. There was no investigation. The company brought in a new barge and a new crew within the week. The surviving deckhand was given $20 severance and sent back to town. There was no workers' compensation, no disability insurance, no accountability. The companies operated under the assumption that industrial accidents were the cost of doing business. Men knew the risks when they signed on. If they didn't like it, there were plenty of others who needed the work. This transactional brutality was the norm. The labor pool for swamp logging was drawn from the poorest segments of Southern society. Black laborers, recent immigrants, men running from the law or from debt. They lived in camps built on pilings over the swamp water. The bunkhouses were long wooden structures with no insulation, no screens, and minimal ventilation. In the summer, the heat was suffocating. In the winter, the damp cold soaked through everything. Malaria was endemic. The camps were breeding grounds for mosquitoes. Quinine was distributed as a preventative, but the doses were often inadequate, and the side effects, ringing in the ears, nausea, visual disturbances, were debilitating. Men worked through fever because missing a shift meant no pay. The food was basic and repetitive: beans, cornbread, salt pork, and coffee. Scurvy was not uncommon despite the relative proximity to sources of fresh food. The companies didn't invest in nutrition. They invested in throughput. A man who got sick or injured was replaced. The supply of desperate labor was effectively unlimited. Pay was structured to keep men in debt. The company owned the camp store. Prices were inflated. A pair of work boots that cost $2 in town cost $5 at the camp store. Tobacco, tools, clothing, all marked up. Men were paid in scrip, company currency that could only be spent at the company store. By the end of a month, most men owed more than they earned. Leaving meant abandoning the debt, which in some states was legally considered theft. Men were arrested and returned to the camps under guard. It was debt peonage, barely disguised slavery, and it was legal. The work itself was a grind that destroyed bodies. Standing in water all day led to trench foot, a condition where the skin breaks down from prolonged moisture. Untreated, it became infected. Gangrene set in. Amputations were performed in camp by men with no medical training, using saws and knives sterilized in boiling water if you were lucky, unsterilized if you weren't. The survival rate for a field amputation in a logging camp was maybe 50%. Hernias were common from the heavy lifting and the constant strain. There was no treatment. Men worked through the pain until they physically couldn't, and then they were let go. Respiratory infections were a constant. The swamp air was thick with mold spores and bacteria. Pneumonia killed more men than accidents in some years. But the companies didn't track that. If a man died in his bunk from illness, he wasn't on the job, so it wasn't a workplace fatality. The body was buried in the swamp, sometimes with a marker, often without. Now let's turn to the innovation that changed everything: the floating railroad. If you can't build a road, and you can't rely on pull boats alone, you build a track that moves with the water. The concept was brilliant in its simplicity. Logs were cut into uniform lengths and lashed together to form a floating platform. On top of that platform, you laid rails, not spiked down, just set in place. The platform floated in the swamp channels, rising and falling with the water level. A small steam locomotive, specially designed with a low center of gravity and high traction, would run on these floating rails, pulling flat cars loaded with logs. The first successful operation of this type was implemented by the W.T. Smith Lumber Company in southern Alabama around 1900. The floating railroad allowed them to access timber that was completely unreachable by pole boat because the trees were scattered through shallow water areas where a barge couldn't navigate. The engineering challenges were immense. The floating platform had to be stable enough to support a locomotive that weighed 10 or 15 tons. The logs forming the platform had to be large and buoyant enough to provide flotation, but also had to be secured tightly enough that they didn't shift under the weight of the train. The rails had to remain parallel and level, or the locomotive would derail. The solution involved cross-bracing, chains, and constant maintenance. Crews walked the floating track daily, adjusting logs, tightening chains, replacing sections that had waterlogged and lost buoyancy. The locomotive itself was a custom piece of equipment. It ran on narrow-gauge track, typically 3 feet between the rails, instead of the standard 4 feet 8.5 inches. This reduced weight and allowed tighter curves. The engine was a geared locomotive, similar to a shay, with all wheels powered and a flexible drivetrain that could accommodate the uneven track. The boiler was small to keep the weight down. Firewood was plentiful, cut from scraps in the swamp. The locomotive moved slowly, maybe 5 miles an hour, because speed on a floating platform was suicidal. Any sudden shift in weight distribution could tip the platform or derail the train. The crew consisted of an engineer and a brakeman. The brakeman's job was to watch the track ahead, signal for stops, and manually set brakes on the flat cars during descents or when the train had to stop on a curve. Operating a floating railroad was a constant exercise in controlled instability. Every movement of the locomotive caused the platform to flex and dip. Water would slosh over the rails. The ties would shift slightly. The whole assembly groaned and creaked. Derailments were frequent. Getting a locomotive back on the rails while it's sitting on a floating platform in the middle of a swamp required jacks, levers, timber cribbing, and hours of labor in waist-deep water. Despite the difficulties, the floating railroad was a massive productivity boost. A single train could move a dozen loaded flat cars, each carrying 3 or 4 tons of logs. That was a day's output for multiple pull boats, moved in a fraction of the time. The system was expanded throughout the Gulf Coast swamps. By 1910, there were hundreds of miles of floating track snaking through the wetlands of Louisiana, Mississippi, Alabama, and Florida. The visual was surreal. A steam locomotive, smoke billowing, whistle blowing, chugging across water on a track that bobbed and swayed. To an outside observer, it looked like magic or insanity. To the men who built and operated it, it was just engineering applied to an impossible problem. But every innovation brought new risks. The floating railroad introduced the danger of drowning in a train wreck. If the platform capsized, or if the locomotive broke through, men and equipment went into the water. A steam locomotive is almost impossible to recover from deep water. The weight alone, 10 to 20 tons, means it sinks into the mud and stays there. Several locomotives were lost this way, abandoned in place because salvage was deemed too expensive. The wrecks are still there, buried in silt, slowly being consumed by the swamp. By the 1920s, the swamp logging boom was peaking. Production numbers were staggering. Louisiana alone was producing over 1 billion board feet of cypress per year. The timber was being shipped nationwide. Cypress siding, cypress shingles, cypress beams. The wood was marketed as eternal, impervious to rot and insects. And it was. Buildings clad in old-growth cypress from this era are still standing, the wood as solid as the day it was milled. But the resource was finite. Old-growth cypress doesn't regenerate quickly. A tree that took 300 years to grow was cut, milled, and sold in a matter of weeks. There was no replanting, no management, no thought for the future. The companies were extracting wealth as fast as physically possible, and the physical limits were being reached by the steam technology and the labor systems they had developed. The environmental collapse was visible to anyone paying attention. Entire swamps were drained and dead. The standing water that had defined these ecosystems for millennia was gone, diverted into the channels and ditches that the logging operations required. Without the water, the cypress couldn't reproduce. The knees, those breathing roots, dried out and cracked. The remaining trees died standing, skeletal monuments to the appetite they had fed. Sportsmen and naturalists began to raise alarms. The swamps were critical habitat for waterfowl, wading birds, alligators, and countless other species. The logging operations were destroying that habitat faster than it could recover. But economic momentum was unstoppable. The companies had invested millions in equipment, infrastructure, and land leases. They had contracts to fulfill and shareholders to satisfy. The logging continued until there was nothing left to log. By 1930, the old-growth swamp cypress was functionally extinct in a commercial sense. There were scattered remnants, trees in inaccessible pockets or protected areas, but the vast continuous forests were gone. The companies shut down their operations, sold off their equipment, and moved on. Some transitioned to pine plantations on the drained swampland. Others simply dissolved. The men who had worked the swamps scattered. There was no pension, no severance, no recognition. They drifted to other industries or other regions, carrying the scars and the memories of work that had broken their bodies. The machinery was abandoned in place. Pull boats were left to rot in silted channels. Steam skidders sank into the mud. Locomotives were stripped for parts or left where they derailed. The swamps slowly reclaimed the ruins. Rust and rot consumed the iron and wood. Within a generation, the physical evidence of the industry was mostly gone, swallowed by the environment it had destroyed. What remains today are fragments, a few preserved pull boats in museums, photographs in archives showing men standing on floating logs or posing next to massive cypress stumps, company records detailing production numbers and profit margins, but rarely mentioning the human cost, and the stumps themselves. In some areas, particularly in Louisiana's Atchafalaya Basin, you can still find them. Massive cypress stumps, 6 or 8 feet in diameter, cut flat 100 years ago. They're still there because the heartwood is nearly indestructible. These stumps are tombstones in a way. They mark the graves of giants and the men who felled them. Walking through a second-growth swamp and stumbling on one of these stumps is a visceral experience. The scale is shocking. You can stand on top of a stump and see the axe marks, the undercut notch, the saw kerf. You can count the rings if the surface isn't too weathered. Each ring a year of growth, hundreds of them, concentric circles of time. And you realize that someone stood here, waist deep in water, and cut this tree down with hand tools. The skill required, the sheer physical effort, the danger, it's humbling. There's a lesson in this, and it's not a comfortable one. We built a nation on extraction. We took resources that had accumulated over centuries and converted them into wealth in a matter of decades. We did it with machines that were marvels of their time, and we did it with labor that was exploited, endangered, and discarded. The swamp logging industry was efficient in the coldest economic sense. It identified a valuable resource in a difficult location and developed the technology and the labor systems necessary to extract that resource at a profit. It succeeded completely, and in succeeding, it destroyed the resource base, the ecosystem, and the lives of the men who did the work. There's no romance in that. There's no glory. There's only the brutal arithmetic of profit and loss, measured in board feet and bodies. The men who worked the pull boats and the skidders and the floating railroads were not heroes. They were laborers doing dangerous work for low pay because they had no better options. They were skilled, yes. Tough, absolutely. But they were also expendable components in an industrial machine that valued timber more than human life. We owe them acknowledgement. We owe them the truth. They built the infrastructure of the modern South, the homes, the docks, the warehouses. Every cypress board in an old building came from their labor. And we owe the swamps themselves a reckoning. What we destroyed is not coming back. Second growth cypress is not old growth. The ecosystem functions that those ancient swamps provided, water filtration, storm buffering, carbon sequestration, are gone or diminished. We are living with the consequences of decisions made a century ago by men who saw only profit and ignored everything else. The technology, the pull boats, the floating railroads, the steam skidders, was remarkable. It solved problems that seemed unsolvable. But technology is neutral. It amplifies intention. The intention here was extraction without regard for sustainability or human cost. The result was predictable. So here's to the men who set the chokers in the mud. Here's to the engineers who kept the boilers running, and the firemen who shoveled through the heat. Here's to the hook tenders who worked alone in the swamp, and the brakemen who rode the floating rails. Here's to the ones who drowned in the mud, and the ones who died when the boiler let go. Here's to the fallers who brought down the giants, and the tug crews who towed the rafts. They did impossible work in impossible conditions, and the world they helped build, flawed and bought with too high a price as it was, is ours. The age of swamp logging is over. The cypress giants are gone. The machinery has rusted away. But the stumps remain, and if you know where to look, you can still find them. Silent witnesses in the black water. Monuments to what we took and what we lost and what we paid. And somewhere deep in the Atchafalaya, a pull boat lies half buried in silt, its boiler cold, its cable rotted away. A steel ghost in a drowned forest. The swamp remembers, even if we've forgotten.